Two blocks, each of mass m, attached with a massless and inextensible string. One of the blocks is placed on the rough horizontal surface of a table for which coefficient of friction is mu. Find out the force exerted by the table on the block if mu is greater than 1. Actually, the situation is here. This is a table on which we have attached one pulley and a block of mass m is placed on this table and it is attached with a inextensible and massless string, and another block of same mass m is attached to the other end of this string. Okay, so now let's apply the forces. So first of all, this is tension of the string acting on this block, and here this is tension acting on the pulley, and here this is tension T acting on the pulley and T on this particular block. So this is the tension. Now the weight of the body. So here mg is weight of this block and the same weight is for this another block also. What else? There is one normal reaction applied by this table on this block, and we know that because of this tension, this block has got a tendency to move in this direction because this block is basically will be going to downward direction due to its own weight. Okay, so to oppose the motion of this block, force of friction will act on this particular block. Suppose F is the force of friction. So here you can understand that the N as well as F, these are two forces which are being applied by the table on this block. Here we have to find the force exerted by the table on the block for a particular case when friction coefficient is greater than 1. But anyway, we know that N and as well as F both are the forces applied by the table on the block. So basically we have to find resultant of these two forces. So here it is the resultant force that we have to calculate here. Okay, so it would be just the resultant force F that can be calculated easily by under root n square plus f square. Alright, so here one point you can see that since this block cannot move vertically, so net force on this block has to be 0 in the vertical direction. So straight away we have this normal reaction equal to mg. So this normal reaction we'll be using here later on. And what about the force of friction? As we know that since normal reaction here is mg, so maximum possible amount of force of friction is equal to the mu times normal reaction. So this is the maximum possible friction which is available here to this block. Okay, so maximum friction is mu mg. So here one thing you must understand that since here friction is involved, so it's not necessary that the motion is always going to take place. No, there may be a case when suppose A is here acceleration of these blocks, then there is a situation when A can become 0 also. So for now we are just assuming the acceleration if it is there as A. So what would be the equation using Newton's second law? So for this particular block which is hanging vertically, as we know the acceleration we have assumed to be downward, so equation for this block would be mg minus t is equal to m into a, and for this particular block the horizontal force here is t and this opposing force is f. So t minus f is equal to m into a. Okay, so first let us think about a situation when this particular block is in equilibrium, when it is not moving. So first let us solve it for the boundary line situation when A acceleration is 0. Let A is 0. In that case, you can see this particular equation would yield T equal to mg, means tension on the rope is mg, and from this equation we know that T is equal to F. Okay, that means the force of friction F from these two equations is equal to mg. And since here we have assumed that motion is not taking place, that means axle A is equal to 0, that means this F mg must be less than or just equal to the maximum possible value of the friction available here. That means mg is less than or equal to mu times mg. That means mu is greater than or equal to 1. So here we have got to know that when friction coefficient is greater than 1, in that case acceleration is going to be 0. So here for this particular situation we have understood that acceleration is 0. In case mu is less than 1, in that case acceleration would be there. Okay, so first let us consider that mu is greater than 1, that means acceleration is 0. So in this case F is mg. So what would be the net force? So for this particular situation when mu is greater than 1, then we know that normal reaction is mg and friction is also equal to mg, because here motion is not taking place. So net force exerted by the table on this block, since it is equal to under root n square plus f square, so it is mg square plus mg square. That means net force F is equal to mg under root 2. So this is the force exerted by the table on the block when mu is greater than 1. And now you can also solve for other situation which is not included in this question. If mu is less than 1, then we know that acceleration is non-zero. Acceleration is going to take place. So in this case friction would be at its maximum because motion is taking place. So friction would be mu mg, and normal reaction as usual in this case also would be mg. So force exerted by the table on the block would be mg square n square plus f square. F is mu mg whole square. So in this case F is equal to mg under root 1 plus mu square. So I have made this as suppose second part. For example, if you say that if first part mu greater than 1, and what would be this force for the second part when mu is less than 1. So for mu greater than 1, answer is mg root 2, and for mu less than 1, answer is mg under root 1 plus mu square.